Okay, hello, Assalamualaikum. My name is Amir Faiz Mirazali from Group 7. My mentor number is AD190006. Our group will discuss about topic 4, Principle of Moments. So for the introduction, the principle of moments is frequently used in engineering and building work where forces have to be balanced to prevent any turning movement. It can be applied both to parallel forces and to oblique forces. If a body has several forces applied to it, which have turning effects in opposite direction, the body will not turn if the total turning point in each direction are equal.
Salam sejahtera, my name is Dunstan Linggir Anak Edwin and I'm from Group 7. Today I'm going to present about experiment theory, procedure and equipment. Firstly, for experiment theory, the theory that has been used is Varignan theorem, and then it was defined which is the perpendicular distance between F and the center of moment, where M equal to F times D. D is distance and F is force. And then the moment of a force indicates the tendency of a body to turn about an axis passing through a specific point. Lastly, the principle of moment states that the moment of the forces about a point is equal to the sum of the moment of the forces component about the point. And then for the equipment that have been used is firstly panel, pivot bar and stop, pulley, nuts, screw, weight hook, cord approx, set of weights. And then for procedure is firstly, set up the panel board as shown in the figure 2 on the left sheet that is given. Please ensure that the pivot bar is in the balance and attach pulley using bolt and nut. After that, hang weight hook from the end hole of the bars, entering the hook from the backs of the bars. The weight of hook, each weight 0.1 Newton. Then add a 1.9 Newton load to each hook to make sure the total of 2 Newton. After that, the experiment has been recorded the value of F1 and F2. Then measure and record the distance D1 and D2. That's mean by measure the F1 and F2 and distance 1 and distance 2. Afterward, move the right hand's weight hook to a hole nearer the pivot bar and load it with just sufficient weight to balance the bar in the level position. Then record the value of F2 and the distance D2. After that, hang right hand weight hook without the weight through the pulley. Then load the weight hook to balance the bar. Next, record the weight value of F2 and the perpendicular distance D2. After that, set up the panel as shown in the figure 3D, then repeated the procedure from 7 to 9 with the cord passing over the left hand's pulley and attached to the lowest hole of the center arm of the bar. Lastly, please fill in the result on the table 2. And the end. That's all from me. Thank you.
Assalamualaikum and hi everyone. I am Ahmad Fathan. My metric number is AD19006776. Today I would like to explain about our observation and calculations based on the experiment of principle of moment. From the result of this experiment, we identify that the total sum of the anti-clockwise moments about at any point is similar to the sum of clockwise moment about that particular point. The turning moment was found by the product of force acting on body perpendicular with distance between force and pivot, where produce the equation of m equal to F times R. R is radius, F is force acting on a body. In the experiment, we use the load to represent as the force F applied and the distance of its line of action from the axis about the turning point. The distance are measured by ruler to get the precise reading. The experimental results were slightly different from the theoretical explanation due to several errors that might occur in the experiment. The difference between experimental and theoretical was within the range of plus minus 0.05. Alright, we proceed to the calculations. There are two sections, left pivot and right pivot bar. For left pivot bar, we simplify into four figures, 3A, 3B, 3C and 3D. The formula we use is moment equal to F times D. F is the force, which is the load we added, and D is the distance between the pivot, which is the four figure for the left pivot is totally the same, because the force times the D is similar for all of the four figure. Force is 2 Newton and D is 0.16 meter, and the equal of moment is 0.32 Newton meter or torque. For the right pivot bar, the moment is slightly different. For figure A, the moment is 0.32. For figure B, 3B equal to 0.308 Newton meter. For 3C, 0.38 Newton meter. For 3D, 0.384 Newton meter. We find the ratio for the right pivot, which is F1 over F2 is slightly equal to 1. F1 and F over F2 is 0.65 for figure 3B. For figure 3C, the force ratio is 0.53. For 3D, the force ratio is 0.42. For distance ratio, for the figure A is 1. For figure B is 0.63. For figure C is 0.63 also. For figure D is 0.5.
Hi, I'm Dinesh Manokaran, metric number CD190311 from group 7. Let me proceed with additional theory. The principle of moments states that when a body is balanced, the total clockwise moment about a point equals to the total anti-clockwise moment about the same point. To be more clear, the principle of moment states that when in equilibrium, the total sum of the anti-clockwise moment is equal to the sum of the clockwise moment. The moment is calculated by force times the perpendicular distance from the pivot D. Besides, when a system is stable or balanced, it is said to be in equilibrium as all the forces acting on the system cancel each other out. Last, the moment or torque of a force about a turning point is the force multiplied by the perpendicular distance to the force from the turning point. Next, let's look at the results. When the right pivot bar's force and diameter decreases, the total ratio will increase. But in our experiment, From figure 3a to figure 3d, the force increases, thus the total ratio decreases. That's all from me. Thank you.
Hello there, my name is Damio and I will present topic lab 4 is principle of moments. I'm from group 7 from section 12. Okay, let's proceed. So the graph is obtained f1 over f2 proportional to d2 over d1 with a positive slope. The system is in equilibrium, no resultant moment. Second is the opinion about the summation of moment from experiment results. The result must be 0 for all figure 3a, 3b, 3c, and 3d. And the sum of anticlockwise moments about any point is equal to the sum of clockwise moments, and the summation of moment is 0. So next is the factors may affect the experiment if the moment is non-zero, the leakage of knowledge during apparatus setup, human error during measuring and data gathering, the apparatus itself that might not be a perfect condition to give the most accurate results. Next is questions. So what is the principle of moment and how moments are achieved? So principle moments state that moments of force point is product of the force and perpendicular distance of its line of action from the point. Moment achieved when the sum clockwise is equal to the anti-clockwise moment when the body is in equilibrium. Next is what does the principle of moment state about the turning moments of forces acting on a body? So principle of moment states that if a body has several force applied both to it which have turning effects in a opposite direction, the body will not turn if the total turning moment in each directions are equal. So next is how to determine the moment in three-dimension body. Moment in three-dimension body can be determined using mathematical approach called vector cross product, which is R is an position vector from point O to any point on the line on action F, MO equal to R multiplied by F. So next we jump to conclusion. So achievement during lab experiment. So understanding principal moment in order to apply in real engineering design, such as bridge, building structure, shaping, construction, etc. And the problem we face during lab experiment, no small weight loads such as 0.05 newtons to balance the bar accurately, and a lot of friction occur in bar joining, and how to define accurate load to balance the bar in level position. Private bar hole is distance is too far, more than 1 inches. And lastly, suggestions conducting the experiment, which is handling carefully during the run, and do repeating data measurement in order to decrease parallax error. And lastly, maintenance scheduling against apparatus, especially on critical link, movement, calibration of dial gauge, and weight scale. That's all for me. Thank you.